good morning to one and all again here. On the second day of International Conference on Multidisciplinary Technologies and Challenges in Industry 4.0. I welcome again the delegates, authors, national and international authors, HODs, and my dear colleagues. We thank you for the kind cooperation that you all have given us yesterday to carry out the presentation very smoothly. We thank you one and all. We also expect the same cooperation from authors of today so that we run the presentation according to the timings. Today, we have two keynote speakers with us, Mr. Puneet Mishra, IEEE Chair, Bangalore Section, and Dr. Silvia from University of Sannio, Benevento, Italy. Madam Vedavati will be introducing the first keynote speaker, that is Mr. Puneet Mishra. Ma'am, over to you.
Good morning to one and all. I am Veda. Will take a privilege of introducing our today's keynote speaker, Mr. Puneet Kumar Mishra. Mr. Puneet Kumar Mishra is a scientist at Indian Space Research Organization, Chair, IEEE Bangalore Section, and Secretary at IEEE India Council. Mr. Puneet Kumar Mishra has done his MTech in RF and microwave from IIT Roorkee in the year 2004. Since 2004, he is with URO Satellite Center, Bengaluru. He has rich experience of RF characterization of 45 satellites and 280 antennas and randoms. He has indigenously developed C-band, Ku-band, K and Ka-band compact range feeds to meet various requirements of ISRO's satellite program. He has played a pivotal role in establishing satellite level EMC facility. He is also responsible for establishment of subsystem level magnetic measurement facility and world's first compact range with 10M wide zone. He has received IETE IRSI Young Scientist Award in the year 2012, ISRO Young Scientist Award in the year 2013, ASI ISRO Space Gold Medal in the year 2014, GE Foundation Award for Academic Excellence and Leadership for the year 2002 to 2004, and 4 Best Paper Awards. He has also developed a payload to study the RF blackout phenomenon during re-entry of space vehicle. He has successfully developed indigenous bus bars for high-power satellites and used in multi-spacecrafts. He has published more than 50 technical papers in international conferences and IEEE transactions. He is a senior member of IEEE, fellow of IETE, and life member of ASI. He is a passionate volunteer and serving as chair IEEE Bangalore section and secretary at IEEE India Council. Presently, he is heading satellite antenna characterization, test and design section. I welcome once again, sir, to the second day of ICM PCI 4.0 in collaboration with University of Sannio, Benevento, Italy.
Yes, sir. We welcome you, sir. Thank you.
I request you to
Thank you.
take over the session, sir.
So thank you very much for inviting me. I would like to thank first of all Dr. Prakash, Principal ETPET, as well as Yogesh, our IEEE student branch chair, who was the person who connected us mutually. And then when I got to know about this conference, I was really happy to be part of it because this year I have ensured that uh, from Bangalore section point of view, we are reaching out to all the colleges who are having IEEE student branch in their college, and whatever support they need from us, very proactively we are reaching out to them and providing all kinds of support. And when I got to know about this conference, I was really happy that because conferences are the best way to network, collaborate, share knowledge, as well as learn something from the experts. And when I heard that I need to share my experiences with ISRO, what I am doing, so I was all the more happy because yes, this is the thing what we are doing on daily basis, and we'll be more than happy to share those information with the delegates of this particular conference. So thank you once again for inviting me, and I hope my now can you just share the screen of my presentation so that I can start. Yes. So friends, I will be going to talk about space antenna systems and how space antenna system is different from other antenna system. What are the challenges involved in this? And in my opinion, where there is a challenge, there is an opportunity. So what are the kinds of opportunities are available in the space antenna system? How we are going to mitigate those challenges and convert those challenges into opportunities? What are the things ISRO has done till now, and how we are going to characterize these antenna systems? So these things I'm going to cover in this presentation. Can you go to the next slide, please? Can you go to the next slide, please? Am I audible or not? Yeah, thank you. Now go to the previous slide. Okay, so you know what are the most important antenna parameters? For any antenna, there will be a radiation pattern, and that radiation pattern consists of main lobe, side lobe, as well as back lobe. They are called minor lobes. Then there is a very important parameter that is called half power beam width. You can see here from 0 dB or 1 to suppose 1 unit So in my presentation, I will be covering basics of antenna, issues of space-borne antenna, trends and test areas in space antenna technologies, shaped and contour beam antennas, multi-beam antennas, and antenna measurement facility. I was talking about antenna parameters and I was discussing that half power beam width. So you can see from 1 to 0.5, what is the angle when main lobe energy is reduced from 1 to 0.5, what is the angle between these 2 points is called half power beam width, and those points are called half power beam width point. Then there is another three parameters, they are interrelated: directivity, gain, and antenna efficiency. So you know, directivity is efficiency into gain, then EIRP, effective isotropic radiated power, then polarization, axial ratio, input impedance, return loss, bandwidth, and effective aperture. So these are the things, they are called most important parameters of any antenna, and then these are the very important parameters which we should be taking into consideration for a space antenna design. Next slide, please. Mr. Dhananjay, can you change the screen to next slide? Yeah. Another very important definition is polarization of a wave. Polarization is why important in a space antenna system is because when you are defining polarization on ground, then it is the instantaneous vector of the electric field. When it is parallel to the earth, it is called horizontal polarization. When it is vertical to the earth, it is called vertical polarization. But when this instantaneous vector of the E field, which is generated from the antenna, is parallel to equator, then it is called horizontal polarization in space, and when it is perpendicular to equator, it is called vertical polarization in space. So when we are mounting these antennas on the satellite, with which reference we are defining the polarization, that is very important. So we have to see that when satellite will be in the orbit, how my antennas will be located with respect to equator, and how my launching probe will be there with respect to equator. Accordingly, we have to define the polarization ports on the antenna. And suppose by any chance, if polarization is reversed, H has become V or V has become H, then entire satellite cannot be used. Why? Because International Telecommunication Union (ITU) assigns same frequency to two different users in opposite polarization. Why it is required? Because you know that spectrum is very scarce. So they want to double the capacity of the spectrum. They can double the capacity of the spectrum by this polarization diversity. So same frequency is going to be assigned to two different users. And when same frequency is going to be assigned to two different users by giving different polarization, and if we have not adhered the polarization what is assigned to you, then you cannot use your satellite because other polarization is already assigned to some other user, and when you are operating in the in that polarization, you will be interfering to them, so it is not allowed. So entire spacecraft which is used for communication purpose will go in waste if proper polarization definitions are not adhered. Can you go to the next slide, please? Yes. Now coming to satellite antenna system frequency spectrum. When we are working on satellites, we will be trying to build high capacity system, because once you are sending a satellite, every day you cannot launch a satellite. You are building a satellite for next 10 to 15 years. So we have to meet the requirement or cater the requirement of next 15 years. That's why we will be trying to accommodate as much as high capacity payload. We will be trying to accommodate wide frequency of spectrum, And because we will be communicating from space to ground, so there will be high power requirement, because from geostationary orbit to Earth, when you are coming, there is going to be almost 180 to 190 dB kind of loss is going to be there, path loss. So to compensate this path loss, you have to pump high power from the space or from ground. So there is a high power requirement. Then continuously there are new and new application areas are coming. So we have to meet those requirements as well as cater those requirements of application as well as service areas. Then once satellite life is over, we have to take out the satellite from geostationary orbit to a graveyard orbit or a satellite parking orbit. Then in the case of low Earth orbit satellites, we are using sensors for this kind of communication. So you can see our frequency of operation starts from VHF to cube, and right now ISRO is working from almost 225 gigahertz to till 43 gigahertz. We are having satellites and covering this entire spectrum. Next slide, please. Yeah. So you can see that what are the challenges or opportunities in the satellite antenna or space antenna system is, first we have to take care of adequate bandwidth, frequency range, immunity from fabrication tolerances, because you can design your antenna, you can design your antenna very nicely, but suppose dimensions are such that you cannot implement mechanically those dimensions, then there is no point of such design, because ultimately you have to fabricate your antenna and you have to fly it. So I always tell that any antenna engineer or microwave engineer should be a good mechanical engineer also, or at least he should have a good capability to grasp the mechanical requirement as well. So you should be working with your fellow mechanical engineer or fabrication engineers or fabrication facilities to know that what kind of tolerances you can achieve, what kind of dimensions you can achieve, what kind of design is possible from the fabrication facility which is available in your lab or outside lab or within India. Then there is a stringent requirement of low cross polarization level. Already I told you that same frequency is going to be allotted to two users in the different polarizations. Suppose you have been allotted H polarization. So for H polarization, cross polarization is V, and other person is using V polarization, which is the co-polarization of other user. So if your cross polarization is poor, or means the energy which is going in the V polarization is poor, means you will be transmitting in V polarization also. So this energy is going to interfere with the second user, and then the performance of second user is going to be degraded, which is not allowed as per ITU guidelines. So you have to make an antenna with very low cross polarization level. Typically it is 30 dB. Then low fabrication cost, because you want to reduce the entire can you go back to the slide? Don't change the slide right now. Yes. Then another constraint is their lightweight, because when you are using a space antenna system, if you are launching 1 gram, you need additional 1.2 gram of propellant to launch it. So that's why all the systems on space, especially antenna systems, they should be lightweight, low volume. Again, your overall volume of the satellite is defined based on the launch vehicle envelope, what is available in your launch vehicle, how much space is available in the launch vehicle, that dictates the overall dimension of the satellite. Once overall dimension of the satellite is fixed, most of the antennas, they are mounted on the outer body of the spacecraft. So you know that because this is the maximum cuboid can be accommodated in the launch vehicle, so outer dimensions are already being fixed. length, width, height is fixed. So your length and width of the antenna is fixed. So that is another constraint you have to take care. Then if you are using a multi-beam antenna kind of system, you need a beam to beam isolation. Then because you will be using for multiple operation, different frequency bands are allotted from ITU. So multi-band, multi-polarization, multi-beam, agility of the beam is mostly important in the strategic application. And then you need a shaped antenna system because you have to cover entire India. Initially, we used to form a circular beam, which is Gaussian beam, but lot of energy is going to be wasted towards the C region. I will show you one typical graph when you are having a circular beam to cover India vis-a-vis a shaped beam to cover India. What are the advantages and disadvantages? Next slide, please. Yeah, so this is the trends in the space antenna system right now. We started with conventional beam, which is circular in nature. Then we came to shaped beam, which is the pattern is exactly the same shape of India. I will be showing you. Then we graduated to dual graded antennas, then multi-beam antennas, then dual reflector antenna system. Reconfigurable shape beams are also future. It is coming. Scanned beams are there. If you see array technology, then from array to we have graduated to phased array, and now we are working towards active arrays. Next slide, please. Yeah, so this is very important slide where we have to see that what are the important electrical and physical considerations in the space antenna design. First and foremost, we should be knowing what is the frequency of operation we are going to operate. Then what is the radiation coverage requirement with respect to gain and bandwidth. Then polarization. Then bandwidth with respect to gain over the band, how much gain variation is allowed, whether it is a constant gain or I can allow some kind of a slope. So this is another requirement. Then return loss and polarization. Power handling is very important. Already I told you, because we have to deal with high power in the case of transmit antennas and extremely low power in the case of receive antenna. So that is another parameter. Then with respect to space, there is a phenomena called multi-packing RF breakdown. This happens mostly when you are launching the satellite. What happens, from atmospheric pressure to you are going to a vacuum. So there is a huge transition of pressure is created and in a very short span of 10 minutes to 20 minutes maximum. So this multi-packing and RF breakdown phenomena happens during those differential pressures. Then another important phenomena happens of EMI. EMC means EMI is electromagnetic interference and EMC is electromagnetic compatibility. Because your spacecraft cuboid is 3 meter by 2 meter by 2 meter, which is a very small volume. In this small volume, you have to accommodate thousands of electronic components, which may be transmitters, receivers, waveguides. So all those things, they are you can see in the close vicinity there is a transmitter as well as there is a receiver. So there are high chances, if electromagnetic compatibility issues are not tackled, then they will be interfering with each other and your entire system is going to be haywire. So there is a guideline, standard guidelines are there. They are called mill standard guidelines, as well as ISRO. Also over the years we have also experienced that whether that mill standard guidelines are sufficient or more for us. So accordingly we have tailored those guidelines. They are called ISRO guidelines, and then we have to meet those limit lines for individual subsystems. And when those individual subsystems, they are going to be integrated on the satellite, they have to meet at a spacecraft level as well. Then these antennas needs to be mounted on the satellite. So mounting, clearances from the sensors as well as other antennas are another requirement. Then size and mass is another requirement. So these are the requirement we have to meet. Another very important thing is which material we are going to use for my antenna, because these antennas, they are going to be the in vacuum environment. Space is a vacuum environment. So for materials, degaussing and degradation due to ultraviolet particles is also an important phenomena. We have to see that when these materials which are working very fine in a normal atmospheric room temperature, but when these same material they are going to be then vacuum, there is a phenomena called degaussing. It happens. How many, suppose degaussing happens and your material is deteriorated, it is no use. Similarly, there will be continuous bombardment from UV particles. Because of these UV particles also, your material characteristics should not be degraded. That is another very important aspect. We have to see that. Then we have seen that antenna alone performance as a designer, mostly when we are in a student or initial years of our design, we always want to design an antenna system which is perfect. But mostly when we are optimizing the design, we will be thinking about only antenna and then trying to optimize the performance. But as a system engineer, or especially when you are a satellite antenna designer, we have to understand that this antenna is going to be mounted on a platform, that is satellite structure. So what will be the impact of that satellite structure on the performance of this antenna? That also needs to be considered in your design phase itself. And if you have not considered, when you will be mounting the antenna on satellite and again testing it or characterizing it, you will find that in some cases, especially in the case of low gain antenna and the medium gain antennas, your radiation performance is going to be deteriorated drastically. And in the case of high gain antenna, mostly cross pole degradations we have observed. Then there are temperature limits, because these antennas they are going to be on the space. In the space, and in space you can see the panel which is looking towards sun will be having at plus 100 degrees centigrade, whereas the panel which is looking towards the cold sky or which is not looking towards the sun, that panel will be having minus 100 degrees centigrade. So you can imagine a thickness of, suppose antenna is 50 mm to 100 mm. Within that 100 mm, one panel of the antenna is looking towards the sun. This is plus 100 degrees centigrade. This panel which is not looking towards the sun, it is minus 100 degrees centigrade. So huge temperature transition of 200 degrees centigrade is happening in 50 mm or 100 mm. So your antenna as well as your materials what you have used, they should be able to withstand this much huge transition of temperature in a very short span volume. Then vibrations, because you will be launching your antenna with the launch vehicle, huge vibrations will be created. So your antenna structure should be able to withstand those huge vibrations. Then grounding scheme and spacecraft charging, this is another important aspect an antenna designer needs to consider, because when you are putting your antenna in the space is actually a plasma environment. Your antenna will be really immersed in the plasma. When it is immersed in the plasma, continuous bombardments of electrons and protons are happening. And when you are using a material, a composite material, these electrons will be puncturing and residing at some depth. Some will be sitting on the surface, some will be at some, suppose 10 mm depth, some 20 mm depth, and they will be continuous deposition of charge will be happening. Once this accumulation of charge is such that it crosses the dielectric breakdown potential, because charge buildup is there, it means voltage buildup is there. So once this voltage buildup is more than the breakdown potential of that particular dielectric, there will be discharge phenomena will be happening and it will rupture your material. So you have to provide grounding path so that you are not allowing to build up these charges. So this aspect also we have to consider when we are designing a space antenna system. Next slide, please. Yeah, most of this I have covered. You can go to the next slide. This portion is also covered. Yeah, you can go next slide. Yes. Now coming to the shaped antenna system. You can see how shaped beams are generated to meet the different requirement. Suppose you want to cover Indian mainland, then top left kind of shaping is required so that Indian mainland is covered. Suppose you want to cover Indian mainland as well as island both, then the top second figure will be the shape of your antenna which will be covering. And suppose bottom left, if you see bottom left, that is global mainland. Suppose you want to cover entire globe and only mainlands where people are residing, then shape of your antenna will be like this. In the case of Asian coverage, your footprints will be like this. So this is the shaped antenna systems which are being designed for multiple applications. Next slide, please. Then now coming to how this shaping is achieved, how we are able to generate these shapes. So one should know that these shaped contours can be created by three different schemes. First scheme is a single parabolic reflector with multiple feed networks and beamforming network. Second technique is direct radiating array antenna with beamforming network. Third technique is shaped reflector antenna with single feed. So out of these three schemes, we have chosen the third one, which is shaped reflector antenna with single feed, because first two techniques required huge amount of RF hardware as well as expensive phase optimization techniques are required. In space, we want to really reduce the number of hardwares as well as complexity. So we have chosen the third option, which is very simple: shaped reflector antenna with single feed. Only one feed is used, so only one RF chain is required. Complexity comes in the generation of this shaped reflector, which we have mastered now, and we are really able to shape any footprint what we want. So but once we are able to achieve this, the entire RF electronics or electronic portion becomes very simple. So the third option we have used. So concept wise, you can see that if you are using a normal antenna, you can see the red beam. That beam kind of radiation pattern is achieved, and through this red beam you can see, you can cover India only. You can see below only one circle is shown. But suppose same beam, if you are pressing, you are trying to redistribute the energy towards this entire India, then you can create this Indian shape. And you can see in the top also this top. So gain wise, if you are using a single beam antenna, gain will be very high. But when you are shaping, we are trying to reduce the gain actually, but we are trying to increase the gain in other areas. So gain is reduced within that circular area, but whereas gain is going to be increased in the remaining areas. So that is the concept. You compress it and you can expand the energy over the Indian mainland, and this is achieved through the entire shaping of the reflectors. So reflector surface profile is designed such that it gives the aperture field distribution to generate the desired shaped beam using single feed. Reflector surface is nominally expressed in the Jernic polynomial or cubic spline. So this is the way we are able to generate the shaping. Next slide, please. Now coming to multiple beam antenna system. So basic concept is, for any reflector there is a optics. One reflector at the focus of reflector, if you put a feed and when you transmit the energy from the feed to the reflector, it will be reflected back, and the plane wave energy or the energy is going to be created in the far field. Accordingly you can generate the footprint. But same feed, if you are laterally displacing in left or right or top or bottom, you can literally shift the position of the beam where it is going. So this concept is being allotted. So at the focus of this subreflector, one beam is there. Another feed is being positioned by offsetting from the focus in the lateral direction. And then using this method, we are able to create multiple beams using multiple feeds. So for generating multiple beam antennas, we need feed cluster. They are used to generate multiple beams. Multiple beam antennas are the recent trends in the communication satellite technology. They provide efficient frequency spectrum utilization, multi-fold reuse of energy, higher EIRP, as well as higher G by T to make the user terminal very, very compact. Another very important thing we have to consider is we are trying to bring the complexity at the satellite level so that the user terminals, what we are using, they are becoming very, very simpler. So this approach is always taken into consideration in the space antenna system design, that let us bring the complexity and all the hard work to the satellite antenna design side, whereas try to make the simpler user terminals. What are the technological challenges are there in the multiple beam antenna technology? There is a stringent requirement of controlling side lobes, coma lobes, as well as cross polarization to achieve high beam to beam isolation. Need of high aperture efficiency, multiple feeds with wider bandwidth are required. Need of communication come tracking feed is required to make they are becoming very, very simpler. So this approach is always taken into consideration in the space antenna system design, that let us bring the width of these antennas to the satellite antenna design side, whereas we try to make the simpler user terminal. What are the technological challenges are there in the multiple antenna technology? There is a stringent requirement of controlling side lobes, coma lobes, as well as cross polarization to achieve high beam isolation. Need a high aperture efficiency, multiple fields with wider bandwidth. Yeah, you can see now here for multiple beam antennas, there is a complex feed networks is required. So you can see to cover entire India, we are having 5 different feeds. And to have these 5 different feeds, what we are finding, we should have 10 different waveguide routings, because 5 is required for the transmit and 5 is required for the receive chain. So for multiple beam KU band antenna, you can see this is the typical structure of the feed as well as beam waveguides. Next slide, please. Yeah, now coming to, I will be slowly touching upon how we are characterizing these antennas. So introduction to the antenna radiation regions. So those who are microwave engineer or antenna engineers, they will be knowing, but for others, I will just touch upon that. When any RF energy is transmitted from any RF source, initially it is spherical in nature. As it propagates, it becomes cylindrical in nature, and further it propagates, it becomes a plane wave in nature. So the immediate vicinity of the antenna region, the fields are predominantly reactive in nature. Then in the Fresnel zone, which is lambda by 2 pi, in between lambda by 2 pi to 2d square by lambda, they are radiating near field regions. They are called Fresnel zone. And once this distance crosses 2d square by lambda, that is called far field region or Fraunhofer region. And the requirement is that distance from the RF source to that distance is 2d square by lambda, where d is the maximum aperture of the antenna or the maximum the diameter of the antenna, and the lambda is the wavelength at which antenna is designed. Next slide, please. Initially, we used to have open area test ranges where we can have 2 big towers, and 1 big tower can be used for transmit, as used as a transmit location, and another can be used for receive locations. So this was some 20 or 30 years before. This kind of structures were quite common and useful also, but now because of multiple mobile towers and radars, this kind of concept is physically or practically it is impossible now. And in addition to that, now there are multiple high rise buildings coming up very very close vicinity to this. So we have moved from open area test ranges to the anechoic chambers where one room is created along with RF absorbers, and then you are able to test the things. But these anechoic chambers cannot be used for satellite applications because satellite antennas are quite large, up to 2 to 3 meters. This can be used for mostly for college and faculty where they are designing antennas they are operating at less frequency, as well as antenna size is quite small, so for them it is okay. But when we are operating in ku car qv band, then this kind of chambers cannot be used. Next slide please. Then there is a again important facility is that is called near field facility. So there are three types of near field measurement facilities are there. So when you are measuring your test antenna as well as the measurement probe, they are very close to each other. They are in the near field region. Then you can do when you are performing measurement. They are called near field measurement. You can perform this measurement by three types. One is a planar near field, cylindrical near field, and spherical near field. So depending upon uses, you can see if you are trying to measure the directional antennas having gain 15 dB and beyond, you can have a planar near field, but you can measure maximum plus minus 70 degrees. Fan beam kind of antennas where you are having wide side lobe or back lobes, you can have cylindrical near field. You can use spherical near field mostly in the case of low gain antennas, which are in the satellite application. We will call them omnidirectional antennas. So there we can use spherical near field facility. Next slide, please. Now coming to the far field, this we will skip. Already I have explained. Next slide, please. Yeah, so mostly for satellite applications, we will be using compact antenna test facility, or compact range is very popularly known outside. So these compact ranges, why the name compact range or compact antenna test facility? Because we are creating far field condition which is 2D square by lambda. I will just give you a perspective that for KU band antenna, 2 meter KU band antenna, if you calculate the far field condition, it comes in kilometers. It means which the antenna which we are designing, suppose 2.2 meter reflector design in KU band, we need a facility which is having 1 kilometer or few kilometers. Then only you can characterize it. Now coming to space related activities. So when you are in geostationary orbit, which is 36,000 kilometers from the ground, you design any antenna of any dimension at any frequency, you will be always in the far field. Now this facility is creating same kind of far field in a small area or a small volume of 30 meter by 20 meter by 16 meter. So that's why this facility is known as compact antennas are tested. So antenna test facility. In our facility till now we have tested 45 satellites, and I was part of all these 45 satellite characterization. More than 275 antennas, in fact now 280 and more antennas and radomes. In this facility, we are performing polarization verification. Whatever parameters I have discussed, those are important for antenna design. All those things are characterized. Polarization verification, pattern, beam sheet, spacecraft body, EIRP is effective isotropic radiated power, saturation flux density, gain over temperature, PIM is passive intermodulation, auto compatibility, and tracking. So all these things we are able to characterize in this facility. Next slide, please. In satellite application, what is the need of this facility? It is required to have subsystem level as well as integrated spacecraft level test. Again, question comes, why we need integrated spacecraft level test when we have characterized my antennas at the subsystem level? So three important things are there why we need this characterization at spacecraft level. Number one, is to verify the mounting of the antennas on the spacecraft. Number two, to verify the spacecraft body induces no disturbance on the previously measured pattern. Number three, to ensure that there is no degrading impact on the spacecraft performance from environmental tests. First one again I will explain, to verify the mounting of all the antennas on the satellite. What does it mean? When you are launching the satellite and you are putting in the geostationary orbit, what happens? Satellite will be always looking towards equator. But if you see your globe, you may be having your atlas or globe, you can see from equator my India is at 22 degrees towards north. When satellite is looking towards equator, your antennas also will be looking towards equator. Then you cannot communicate with the India. To communicate with the India, what is required? It is required that even though my satellite is looking towards equator, my antenna should be looking towards India. So it means 22 degrees north. This kind of tilt is required on board so that my antenna can look towards India. So this tilt is mechanically provided by providing some kind of a sims or some kind of a tilt. So this is provided mechanically and this is aligned mechanically. But RF wise performance cross verification is required for this, because we have to really see that this 22 degrees what we have given mechanically, it is really 22 degrees or 21 degrees or 20 degrees. So that's why a RF characterization and then plotting up the measured pattern on the globe only will tell us whether antennas are really aligned properly or not. Second important thing, already I told that antenna, when it is mounted on the satellite body, what is the impact of spacecraft body also we have to study. So that is the second objective. And third objective is, when satellite comes in the CATF, it comes at the fag end of the satellite realization cycle. In fact, CATF test is the last test on the satellite before it is moved to the launch pad. Before coming to CATF, satellite has underwent multiple environmental tests. Thermovacuum. Thermovacuum is a chamber where we are creating this plus 100 degrees centigrade to minus 100 degrees centigrade transition. Vibration. Vibration, we are really simulating the launch loads so that before the hand we will be having information whether it will be really able to sustain the launch vibrations or not. And then acoustics. Acoustics is another important. I will just give you a small perspective. When launch happens, within 3 kilometer area nobody survives. So before launch we have to cordon off 3 kilometers area. One, in fact, the launch control center what you are seeing on the TV, they are located beyond 3 kilometers. So if any bird or any animal is left over within 3 kilometers after launch, what we have found, they are dead. So this kind of huge amount of sound is being generated. So we have to test creating those kinds of acoustics and really test the satellite that whether it is going, all the electronics, they are going to survive those things or not. Next slide, please. Yeah, so already I explained what was the past, present, and future. When we are going towards 5G and beyond, initially we were covering India with circular beam, then we shaped and we started generating the pattern with Indian. Now, same in India, we are going to cover with more than 40 beams so that we can pump high data and with same size of antenna, because antenna size we cannot increase because of limitations what I have already told. Then there is a concept of using this multiple beam antenna covering entire India with multiple beams. And when beam sizes are reducing, your beam width is reducing, your characterization complexity is increasing. You need a very highly sensitive receiver, highly accurate positioning system, as well as very low cross pole should be there for your facility. Next slide, please. And another very important aspect is creation of microgravity, because these antennas are designed for space. In space, there is a microgravity, and then because in space there is a microgravity, the attachment or hinges what is designed for these antennas, they are designed for microgravity. But when you are opening these antennas on ground, you are creating 1G effect on these hinges. So what happens to entire antenna sags? When entire antenna sags, when you characterize in that condition, you will see there is a shift in the pattern which you don't want. accurate measurement will be there, we have to create a real space condition. So how we are creating microgravity on ground, I will explain in the next slide. This is skip. Please go to the next slide. I have already explained how we are creating far field condition. Yeah, when facility description is, you can see amplitude taper less than 1 dB, phase taper less than 5 degree, cross polarization 38, shielding effectiveness 80 dB, frequency up to 200 gigahertz we can do, but presently we are utilizing, because of our RF instruments, up to 40 gigahertz. We are having a very accurate positional system of the order of 0.01 degree, because when we are trying to characterize antennas with beam width of 0.6 degree or 0.5 degrees, then we need angular precision of 0.01 degree kind of thing. We have to test a satellite, so we are having heavy duty positioner up to 6000 kg, which we can mount on that. Receiver sensitivity is minus 110 dB, that kind, because we will be dealing with really low power. Next slide, please. Yes, this is the fixture. This is called 0G fixture. With this fixture, we are able to create a microgravity. You can see these are the deployable antennas on the satellite structure. We know what is the mass of this antenna, which we know what is the CG line passing through this antenna. If we will use the concept of physics R equals to mg thrust, we can apply at the CG line. Then we will be creating a weightlessness condition, which is called a microgravity condition. So this is the concept we have used, and we have indigenously developed this structure, so that for various satellites we can create a microgravity on ground. Next slide, please. Now coming to how we are measuring the radiation pattern by using this grid patterns, microgrids. To cover India, we need -5 to +5 degrees. Elevation wise, -3.5 to +3.5 degrees. And then we are creating a raster scan, and I will show you how pattern look like. Next slide, please. I know I am not having very less time, so you can see when we are measuring this with actual, dotted is the subsystem level result, solid line is the system level result. You can see, because this is a high gain antenna with 33 dB, not much variation is seen. But whereas in the case of cross pole, you can see there is a distinct changes is being observed from the dotted to solid line. So this is the way we have seen that this is the impact of a spacecraft body. Again, same characterization is being done when satellite is really in the orbit. We have measured again radiation pattern, but in space we cannot go beyond certain limit, otherwise we'll be interfering in the neighboring countries. So that's why that scan angles are very limited. You can see red contour is very limited, whereas blue is very wide, because blue is done in the facility, whereas the red is in the actual space. Still you can see we are able to capture the entire variations, and they are exactly overlapping. That shows that the quality of plane wave which we are creating in our compact range is a real simulation of the space environment, and they are excellently matching. So this has drastically reduced the requirement of in-orbit testing, which initially we used to do months together. Now we are finishing the IoT measurement within 1 week, because we will be taking some sample measurement and we'll be matching with the measured results in this facility, and if they are matching, we are declaring the satellite operational. Next slide, please. This I will skip. Next slide, please, so that I can take few questions. Thank you very much. If any questions are there, I will be more than happy. I can see I am still having 5 minutes time. You are muted. We are not able to hear you.
Sir, thank you so much, sir.
Thank you.
Sir, thank you so much, sir.
Thank
we'll
you.
take some questions.
Yes, I will be more than happy to take questions. That's why I finished 5 minutes before.
Yeah, we have seen you very much on time. and all the slides had a lot of descriptions with it. Wonderful, sir. Sir, I could see one question on the screen, which Dr. Ashok Sukla sir has asked. Can you see the screen, the question on the screen, sir?
Yeah, this is which type of material or coatings are applied on the outer surface of spacecraft for EMI shielding in space? Yeah, so for EMI shielding, we are not applying actually any coating. For EMI shielding, what we are trying to do, we are trying to use 3 aluminum thick plate so that we are able to restrict most of the interference which is from the nearby object or from the outer space. So we have optimized, because more than 3 if we are putting, the amount of advantage where we are getting is not much. So this is the optimized number what we are putting in all the places wherever we are seeing there is a gap or there is opening. So all those areas are covered with this 3 thick aluminum sheet. Next question. Very good question, Suklaji. You have asked this: how is the grounding of accumulated charges due to continuous bombardment of charge UV particle in space on the antenna is carried out to avoid the buildup of high voltage? Yes, I already explained that we will be having continuous grids of metal wires will be used to provide this grounding. What we have seen, that if we are able to provide, we are able to create a grid of 1 centimeter by 1 centimeter through these wires which are conductive in nature, so charge buildup we can really avoid. And that's why we are putting this grounding strips or grounding wires on the entire antenna structure, and sometimes even they are embedded in the case of dual graded antenna. So this way we are trying, and these electrical wires, they are grounded to the structure, so that as soon as any electron is hitting near the build-up area, we are trying to capture, because this will provide the least resistance path. So electrons will be coming and residing on this, and then we are trying to ground them. So this is the way we are trying to avoid this charge buildup. And wherever, even for the satellite structure also, we are putting copper metallic tape wherever this kind of CFRP or other materials are being used. So again we are going to create this 1 centimeter by 1 centimeter entire structure, we will call a grid, so that we are able to provide in the very close vicinity of any where charge buildup is possible, we can avoid this charge buildup and we can provide a least resistance path.
Thank you so much, sir. Nicely told. Sir, we have another question from Dr. Shiva. Sir is asking, the question is on the screen.
Could you give some ideas on space antenna materials, shape memory alloys, and 4D printing? Okay, Dr. Shiva, you are talking about futuristic technologies. Yes. What happens? Shape memory alloy we are not encouraging in the space, because they are having a magnetic characteristic. Then only you can have this memory build up in your material. What happens? We are discouraging uses of magnetic material in the space, because when we are using magnetic materials in the spacecraft, there is a concept of deorbiting of the satellite. When we are putting any satellite in the space, we try to have satellite in the orbit, but because of this atmospheric drag as well as earth magnetic field and as well as earth gravitational field, they will be always trying to come towards earth, so they will be drifting from the orbit. So we have to avoid those driftings. If we have to avoid those driftings, we have to utilize the propellant which will be always we will be firing, that is called station keeping maneuvers. We will be always trying to keep the satellite in the orbit. Once we are using these magnetic materials, this deorbiting phenomena happens more frequently because there will be bending moment created between the earth magnetic field and the magnetic field generated on the spacecraft body. So this will create a bending moment, and we need more propellant to stabilize the satellite. So satellite stability becomes a concern. So that's why we are not encouraging any ferrous material or a material which is having this memory concept, because memory comes only with the ferrous material. 4D printing, yes. Coming to this 3D printing, yes, we are in fact we are encouraging if we can have a concept of 3D printing, so that complex structures, especially in the case where we are seeing there are multiple joints, because when there is a joint there is a leakage probability, there is a EMI problem is happening. So we want to avoid those joints, and with the help of this 3D printing we can avoid those joints and we can reduce the EMI things. 4D printing, actually I am not very aware, so I will not be able to answer that, but yes, 3D printings we are encouraging and we are using in some cases as well.
Thank you so much, sir. We have our principal, sir, also on the screen. Sir, Dr. Prakash, sir, if you would like to ask something in person to our own Puneet K. Mishra, sir.
No, absolutely no, sir. I think thank you so much, sir.
Thank
Very
you.
nice of you. Thank you so much for taking time and being a part of this international conference. Very informative session, sir. I think many things, even I don't come from electronics background, but still, so fundamentally we are able to reach out to the students. Many fundamentals also we are missing out. We never really think of all those fundamentals. But very nice, sir. Thank you so much, sir. Very kind of you.
So
Thank you very much.
Yeah, a lot of questions are floating, but having said that you have done all the presentation on time, so we will value your time as well. We will take the last question, which is being asked from Professor Anita R. Madam is asking, sir, which type of feeding network is used for multiple beam antennas?
So mostly we are using waveguide feeding networks, corporate feeding they are called. So but because I am telling that we are going to use for higher power applications, and when we are using higher power applications, mostly we are using this multiple beam antennas in KU and KA band. So in that time we will be depending upon which frequency we have to choose that particular waveguide dimension, and we have to use for feeding the network.
So as you can see on the screen, sir, a lot of thank you about the session is coming. A lot people are appreciating that it was very informative. And to reveal the age group of the audience who are with us, we have one audience whose age is nearly 15, and we have another audience who is of 67. So all the kind of audiences are here, sir, and they all are appreciating equally. We could see a lot of messages. Next to me, I have Dr. Yogesh, sir, who would like to speak to you in person.
Yeah.
Go on, sir.
Sir, thank you very much for your kind time. On behalf of East Point IEEE student branch, I thank you wholehearted, and we would also assure you that we will be making more members in the coming days.
Yeah, that is very important.
Kind of you.
Thank you very much.
Thank you very much once again.
Thank you very much. Thank you. So I hope I can leave now, because I have to join some other session now. So I can leave now?
Sure.
Thank you.
Sure,
Thank
you can
very
leave,
much.
sir.
Yeah.
Now I will call for Anita Madam.
This camera has to. So, dear audience, that was the end of the first keynote, and we have another guest who is already was joined on time, Miss Sylvia ma'am. So, I request Shilpa ma'am to formally introduce the speaker of the day.
We have next speaker, Dr. Sylvia ma'am. Dr. Anita from EC department will be introducing the keynote speaker, that is Dr. Sylvia ma'am.
But like this, hold up.
Myself, Dr. Anita, and it's my privilege to welcome the keynote speaker for today's session, Dr. Sylvia ma'am. Dr. Sylvia is an IEEE senior member, the industry liaison for the IEEE Italy Joint Council BTS chapter. She is a member of the Academic Senate at University of San and the national reference for the Sirapa BTW Italy Sciences and Technologies Task Force. She graduated with law in electronic engineering at the Faculty of Engineering of Federico II University in Naples. She received the MSc in Management from the Massachusetts Institute of Technology, Sloan School of Boston, USA in June 1992. Since 2004, she is a researcher with the University of San di Benevento, where she teaches signal theory and innovation and telecommunication networks, courses for the degree in electronic engineering and the optical and radar remote sensing as PhD course. She has authored 76 research papers in reputed journals and conferences and co-authored many chapters. She is part of the telecommunications and remote sensing group at the University of San Diego, and her research interests mainly deal with signal processing, remote sensing, image and satellite data analysis, machine learning applied to satellite data, ESI, Copernicus mission, cognitive radar, sensor network, telecommunication network, and smart grid. She was awarded in 1990 with the Marisa Belisario Prize from the Homonymous Foundation and with the Marisa Belisario Scholarship from the Italcel SPA company. She has been with Italcel since September 1992. She served as the chief of some production lines at the Santa Maria Capia Venture factory until January 2000. After that, she won a public competition and started working at the Center for Data Processing in the municipality of Benevento from January 2000 to January 2004. In February 2004, she won a researcher contest at the Faculty of Engineering at the University of San Diego, Benevento. A hearty welcome to you, ma'am. The session is over to you, ma'am.
Welcome, ma'am. Welcome to this international conference.
Good morning to everybody. Namaste.
Namaste. Thank you so much. Good morning.
Namaste, ma'am. Namaste.
Thanks to you. Good morning. So I start, I think, right? I share my screen.
I'm requesting you to share the screen, which is coming.
Okay.
Yes, ma'am. We can see your screen. Please hit on full screen.
Yes. Do you see the full screen?
Yeah, we can see that, ma'am. We are seeing you. You cannot see yourself, but you can continue, ma'am. Audience can see you and your screen both.
Okay, thank you. So, first of all, good morning. Namaste to everybody. I started with this slide because, I feel to thank you so much for everything that you have done. To all the organizing committee, the chief patrons, the patrons, above all to Shilpa Patil, for all the efforts that everybody has put to make this conference so successful. And in particular, I need to thank the principal, Dr. Prakash, and my friend and colleague, Dr. Yogesh, that I had the pleasure to meet in person last December during my visit to the East Point College, and also because they allow this great collaboration between the East Point College of Engineering and Technology in India and the University of Sannio in Italy. So it's like a long bridge that we have created among these two universities and these two countries. I really hope that this can bring something in the future. Also, I want to thank you for yesterday, because the opening ceremony was really emotional, really touching. I put here some pictures because I was with you last December. Here I'm with the principal, with Yogesh, and with my friend Zarzar Lin. So yesterday I had the sensation to be, almost there with you. I'm so happy I could join in person all of you and to stay in the East Point College. I hope to be there in the next future again. Here we are in the same place where you are now, I think. I think it's the same place. I took a lecture on satellite remote sensing for monitoring our planet. And also was very emotional, the ceremony, because you dedicate a particular space to Dr. Venkat Pati, and he really deserved this, because thanks to him, the Indian students have such high-level educational institution, and I think that Dr. Venka Pati is an inspiration for all of us, a kind of guide and a model for us and for the future generation. And here is last December with Yogesh, when we visit the place where there is the tomb. So it was very emotional. So thank you again for the ceremony of yesterday. So my speech of today is about the big data revolution and the industry 4.0. In particular, the idea is to see the impact, to analyze the impact on operative fields and advancing the tools for data collection and analysis. I will analyze some operational fields on which Industry 4.0 is having an impact, introducing some data collection and analysis tools more suitable in reference to a particular case of interest that I will present, and I will give some final observation related to the India country. Tell me if the slides don't move, if there is any problems, okay? So the fourth industrial revolution is transforming virtually every human activity. The way we do things, the way we use our planet's resources, the way we communicate, interact with each other as human beings, the way we learn, our way of working, the way we govern, and the way we do business. The size, speed, and scope of the phenomenon are unprecedented. Just a few decades ago, the internet connected a few computers to a few sites. Today, virtually every human being can connect to a network that spans the entire globe and provide access to the largest repository of information and knowledge ever created by humanity. And these are the words of Joe Kieser, President and CEO of Siemens AG. The fourth industrial revolution, as we know, concerns society as much as business and technology, and in this latter case, affecting the production sectors and what is called Industry 4.0. All areas of industrial production are influenced and transformed by Industry 4.0. From order management to product recreation, from research and development to delivery use, commissioning, and even the recycling of products. Machine-to-machine communications and continuous access to the internet have paved the way for the Internet of Things, the so-called IoT, and cyber-physical systems in the industrial sector. Millions, billions of data are transmitted, stored, processed, uploaded, and downloaded from databases and from the internet in general. The world in which we live and work is increasingly connected, and the Internet of Things has become the reference model. And in this specific case, it has taken the forms of the industrial Internet of Things and the cyber-physical production systems. Industry 4.0 started from the industrial paradigm and then extended to other areas, such as that of medicine, aeronautics, home, automation, mobility, and many other sectors more closely connected to the world of services. The integration of embedded systems, the Internet of Things and cyber physical systems have become so pervasive and as to produce an unprecedented impact on many aspects of daily life, transcending the boundaries of industrial production and allowing the creation of smart home, smart car, smart grid, smart city, smart mobility. My presentation will analyze, as I already highlighted, some operational fields on which the Industry 4.0 is having its impact. And I will discuss some data collection and analysis tools with reference to some case of interest. The Industrial Revolution moved from the first Industry 0.0 through Industry 2.0, 3.0 until what we called now Industry 4.0, moving from the first mechanization system with steam power, weaving loom, to mass production, assembly line, electrical energy, automation, computers and electronics, and finally, nowadays, Industry 4.0 include cyber physical systems, Internet of Things, and connected networks. The birth of Industry 4.0 started in 2011 April. Industry 4.0 takes its name from the industrial plan of the German government, presented in 2011, and then implemented at the end of 2013. These included investments in infrastructures, school, energy systems, research institutions and companies to modernize the German production systems and bring back German manufacturing at the top of the world, making it globally competitive. So what happened in that years was that many countries in Europe try, and all over the world, try to imitate what the German government was doing. The idea of the German government, the goal, was to bring the German manufacturing back to the top of the world by exploiting the new possibility introduced by the technology that in that moment was growing. So the evolution of Industry 4.0 started from the success of this project born in Germany that was called Zukunft Project Industry 4.0, and there were very dedicated studies from some consulting companies plus university to move to the fourth industrial revolution. The fourth industrial revolution begins. What was important were the enabling technologies of this fourth industrial revolution. So the enabling technologies of this revolution were defined to characterize this particular phenomenon. These enabling technologies are many, but they are grouped in 9 main categories that are as listed in this slide, from advanced manufacturing solutions, additive manufacturing, augmented reality, simulation, horizontal and vertical integration, industrial internet, cloud, cybersecurity, big data, and analytics. And all the details are in this slide. I will share, obviously, my presentation. So, since I don't want to go ahead of my time, I prefer to take some hints from each slide. But here you can find all the particular details of these enabling technologies. These are some studies done in Italy by this institution, Federmeccanica, in 2016. I like to share these studies with you because I think that a lot can be taken and replicated, or at least analyze and discuss to see how much similarity there is between the two countries, our country and India, in the specific case, because I'm thinking to each of our two countries, So in this case, we see that the survey that was done resulted in the 60% of the sample company which declared to have adopted at least one of the enabling technologies, while just the 36% declare in 2016 to have adopted nothing. Among the companies which have adopted at least one enabling technology, they consider as priorities the productivity improvement and the reduction of the time to market through the digitalization of the manufacturing. They believe that a gradual technological approach is more suitable to make the own industrial reality evolve. Moreover, digitalization makes the difference between advanced companies which have adopted enabling technologies and traditional companies. Here there is a full scheme of the supply chain management in which we can see the management of the supply chain in the industry, including the supply chain, the production supply chain, the supplier, the distributor, the inventory, visibility, manufacturing, and logistics. And all of these key terms, these 8 key terms defined by the supply chain management, are involved in this process. just to say that all these key elements had to adopt enabling technologies if they wanted to move toward the process and the development highlighted by the Industry 4.0. The set of enabling technologies must lead to creating a competitive advantage in terms of Industry 4.0. Here we can see how the main objective of Industry 4.0 is to improve the perceived quality of products based on customer feedback, customer satisfaction, thus optimizing the related industrial processes, increasing their flexibility, speed, productivity, and quality. And this is the reason because all the 8 key elements in the slide before are important. They all together must participate to the process. Here we have an example of what is called lean manufacturing, and all the process of transport, inventory, waiting time, defects, quality monitoring, and so on are all part of the lean manufacturing aspect. The lean manufacturing is strictly related to the lean management through investigation, instruction, tool controls, the qualification of specific personnel, measurements, calibration, inventory, and all these activities that are represented here. What was important in the Industry 4.0 process was realizing a particular aspect of the process that was not possible before, when the technology was not ready to allow this. The real key factor has been, because now is the present, it's not about the future, the digitalization of the processes for the creation of what are called digital twins of production processes. What became necessary was to overcome the phase in which the goal was to make vertical efficiency sub-process by sub-process, but the realization of the fourth industrial revolution instead involves the integration of individual business processes along the entire value chain. So this slide is therefore related to making a digital copy of the reality to work on in advance, to anticipate what was going to happen in the production chain. So what happens? The Industry 4.0, especially in the production field, was able to give some guidelines, for instance, to design and simulate the product in a digital environment is what is called the digital twin of the product. Some examples are in this slide. So in particular, the digitalization of the product allows to define its geometry and simulate its behavior in the most varied ways without the need to build and use physical prototypes. And then perhaps the workers after measurements realize that the first prototypes do not fit the standards, and so they have to come back. In this case, the digitalization of the product allows to check everything before the production. So the result is a digital model, what is called digital twin, that represents the product in all respects. Together with this, there is the other aspect of the so-called digital twin of the manufacturing process to verify its manufacturability. The same things happens for the manufacturing process, in which the human behavior, the machines, their interaction can be studied in detail in advance. Appropriate hardware and software systems are able to define and simulate every aspect of the process to be carried out in a production plant. And the digital twin of the factory. So engineering the factory modification, how the factory must be changed, improved to make all the processes and the production working and be successful. So interactive product, process and factory into a single data model. This is the goal of the full production execution process. All real production and field data are available and contribute to update the digital product process model in this life cycle and data analytics. So what happens is that in the Industry 4.0, we have together some particular main aspects like ubiquitous internet, machine-to-machine communication, advanced analytics, but all around there are some particular domains that must be underlined, like asset utilization, workplace safety, quality control, supply chain management, product monitoring. These are the domains of the Industry 4.0 with the details related to each of these aspects. For instance, let's take the supply chain management. This means to take into account real-time monitoring, logistic tracking, route planning, quality checking. For instance, just reading to these only to these elements, we see how the logistic tracking, the route planning are very important in the supply chain management. I highlighted these aspects because I will focus my case study on something very related to this aspect as we will see in a few slides. This is a complete smart world scheme in which everything in a smart city can interact, from buildings to people in the cars, people making jogging or just walking, people at work or people in their houses, or the farmers. So everything can be connected through smart devices and through internet and a connected network which put all the data collected by the sensors together. This is a slide on the Internet of Things, just to put into evidence how over the years the data have grown so much to reach in this year, to 2020, 50 billion of data coming from the so-called Internet of Things. So there is an explosion of a connected possibility, but also an explosion of data to be managed. So the main challenges are the data challenge. So the new request for archiving, processing, management, some data, new algorithms, model visualization techniques, increase standardized approaches, reduce redundancy. These are all big challenges related to data storage and processing. Another challenge is the data exchange with partners to reduce the gap between, for instance, production and the ERP, the so-called enterprise resource planning level, to monitor inside the factory the data, to share with the partner the process of the production. And so this is another very critical challenge aspect of information sharing, because not be able to do this effectively means loss of competitive advantage. Instead, being able to exchange efficiently the data means fast intervention, just-in-time manufacturing, and so be successful in the industry fields of today. Another challenge is the process flexibility. It's important to bring the standardization of the processes and their synchronization between the various departments of the same company or of connected companies to achieve flexibility in an effective way. All these challenges are related to another important challenge that is security. Monitoring of the devices for updating and security issues, need for updating and for protection against viruses and cyber attacks. Training and skill development is the last but not the least challenge, and is related to the ability to maintain the workforce, to create efficient incentives, training, and need for new skills. From the Industry 4.0 and from everything that I highlighted, training and skill development is the natural consequence, because what was clear from Industry 4.0 was the need of new jobs. So the future of jobs, of skills and workforce for the fourth industrial revolution was completely new. Here we can see how the required skill changed completely. These are the top 10 skills required in the companies, and this is done from the World Economy Forum, so it's worldwide, from 2015 to 2020. So we can see how the position of the skills required for the employees, for the workers, is very different. On the third place, there is creativity, for instance. Okay, critical thinking that is going up, in the ladder of this list. If we go here, we see, for instance, how Italy and India are the first two countries as a percentage of disruption skills. That means as a mean overall over the world, 35% of core skills will change or have changed between 2015 and 2020, but this is a mean. In Italy and India, for instance, the percentage was higher, was 48% and 42%. This means that perhaps we were less ready with respect to other countries, and we had to change much more the skills for the Industry 4.0. And on the left, there is all the aspects from financial service to basic and infrastructure to mobility, the disruption across the countries and the industries that had to change because of this. These are the change of occupational level, and this is the change of labor market. See how Asian labor markets are on the first places, and then there are all the other one. So the data challenge was that most companies already use data analytics in the form of reports and diagrams to enable execution of their activities. The latter are largely processed on well-structured data from operating systems that comply with the predetermined relationship. Big data, however, does not follow this structure model. The flows are all different, and for this reason, it is difficult to establish common relationships, but with their diversity and abundance, it comes opportunities to learn and develop new ideas that can help changing the business. This is the big data evolution, and so we can see how over the time the big data size, complexity is growing. What I want to underline is the need for new tools for data analysis. So moving to Industry 4.0 has forced many people to change their way to process and analyze data. Big data couldn't be processed in the standard way. So what happened over the last years was that new tools were used, and so we started talking about artificial intelligence, including all the techniques enabling computers to mimic human behavior, machine learning models and algorithms, that is a particular subset of artificial intelligence techniques, and inside the deep learning, which represent a subset of machine learning, which make the computation of multi-layer neural networks feasible. Other softwares like R, for instance, were also used with the particular programming language like Python, for instance, and others. But what is important to consider is that the data analysis was no longer possible with the traditional processing tools. Related to the application of the applications which characterize the Industry 4.0 and related to the smart world and the smart mobility, I'm going to present in the time. How much time do I have for this last part? How much time do I have for this last part? When I have to finish, okay, I go ahead, I don't hear anything. So this case study that is related to a smart way of mobility is a case study presenting the net chip paradigm, and this net chip paradigm is related to a mobility network connected through a chip architecture. Chip stays for connected, heterogeneous, intelligent, and personalized. In particular, this project was realized with other partners besides the University of Sannio. We shared different skills for this project. This project resulted in some publication to conferences. Here I put the references, and to a report of a technical report just published in June 2020. And the idea of these intelligent transport system strategies is that smart mobility, as we have seen from the slides before, is an important element to succeed in a new paradigm where Industry 4.0 is emerging. So mobility and smart mobility is a very important key element, key factor to succeed. So what we did was to develop, and we presented this project to a call of our university ministry. This project, this NetChip project, wants to achieve too many objectives fixed by the National Plan for Intelligent Transport Systems. Managing multimodal mobility through ITS, this intelligent transport system, using open platforms, and promoting smart mobility. So the project was considering the direction given by Europe, and through this direction, following all the steps to reach more efficient transport modes, improved the vehicle energy efficiency, and be able to give better information to user, also to improve traffic management. The final result of this project was to identify the necessity of smaller, lighter, and specialized vehicles. Besides this, to identify more transit trips, more and flexible, and the necessity to use no conventional fuels vehicles. So this NetChip project is all focused on smart mobility. The idea was to propose an innovative transportation system based on the concept of mobility as a service maps, and the system is based on small road vehicles without fixed paths and schedules, which will be adapted in real time to satisfy the customer requests, and considering also traffic congestions and the availability of other transport services, with the possibility to share or not the trip. Just a second, because I'm reading a message. I think that I have less than 10 minutes. So I go through this slide to go to through the motivation of this project. So this project was based on public transportation system, on small and low emission vehicles without fixed routes and schedules, and the possibility to share or not the trip. The user can require the ride through a mobile application which gives his or her location, and the system will provide the service considering all user requests, vehicle availability, intermodal opportunities, traffic congestion. To implement this system, it is crucial to have real-time information on vehicle positions, other public transit supply, traffic and environmental conditions. The monitoring system that should be implemented must be able to obtain all real-time information necessary to guarantee a sustainable mobility in accordance with the project objectives. In particular, a wireless sensor network will be used as distributed data sources to gather real-time traffic and environmental data in order to build descriptive and predictive models and plan the best routes to reduce road congestions and consequently urban pollution and greenhouse gas emission. So this is the chip framework, and the key features are related to the innovative part. So innovation is related to the possibility of the user to book a mobility service, the system that is able to identify the travel times, and the system which provides a single source destination, which provides not a single source destination service for the user, but more than one possible travel alternatives. Okay, this is all the functional frameworks, but I want to go a little bit ahead to let you see one thing that is very important. The main challenge collecting all this data from a large number of different and heterogeneous sources was related to big data analytics and machine learning techniques. So what was important was to consider all the traffic conditions, all the local pollution, and also the weather forecasting. So there were some sensors and measurements to put inside this model. The sensor networks and wireless sensor networks, the big data analytics, the analysis and statistical model, the transport and the mobility, to realize a robust predictive control of all the parameters. So these are the different sensors. I wanted to go ahead with some slides. This is an example of some sensors put on the lights along the street. And weather, pollution, and traffic were considered all together because they sensors related to each of these variables had to collect information on number of vehicles, moving people, flows, speed, mean speeds, pollution as concentration of pollutants, weather as monitoring of weather data. And we realized as the first part of the project a lot of data analysis. These are just a scatter plot to put in correlation pollutants and weather condition or other information related to traffic and weather conditions. So what was important was to consider in this model how sensor networks, databases, and web sources could feed the machine learning model to produce analytical models. So the main algorithms were related to predictive analysis of traffic and pollutants conditions, real-time anomaly detection, and decision support system to perform mitigation actions. Okay, I skip some slides. These are this is the way in which we simulate the model. So this is a request. And then the user goes to one of the parking position, waiting for one of these small truck, and the small truck is moving on a specific pathway. It depends on the traffic and all the information. At the end, the truck will reach the user. These are the position of this kind of sensors, in this case for pollutants and traffic monitoring. These are all the part of the work package. I'm going to skip this. I want just highlight that what was clear, the final conclusions coming from these micro and macro traffic models, from the artificial neural networks used in the project. Some were completely developed from zero, and through the dynamic routing algorithms, it was possible to highlight the importance of flexibility, of using small trucks and to satisfy the user's requirements. Besides this is the example of a control center to employ these communication technologies. The conclusion that I want to highlight for this case study are this one. So what was important is that the project required multidisciplinary competencies. So we had to put together different skills and backgrounds from the researchers from the university. The project had to follow the direction given by the European Union, so it is specific of the country where it must be applied. New architectures for Industry 4.0 will be able to catch data from wireless sensor networks, store and manage data in cloud system, and generate necessary output information. Many issues and challenges are data security, device functioning, the control of failures, and so on. And the biggest aspect, the biggest result in the specific case study of the NetChip project that I presented is related to the identification of flexible routes and small vehicle to be used. I'm highlighting this part because I want just to leave this last slide with these observations to discuss together. Which opportunities for Indian country if we would like, to transfer or just to discuss this project, for instance, as other projects. What is important is that the Indian country is demonstrating to be interested to deep collaborations worldwide with many universities and companies. An example is what we did between the East Point College and the University of Sanyō. So other opportunity is technology transfer, the replication of successful stories, advanced manufacturing, and the ability to adapt methodologies that have worked in another country to own reality. What made me amazed when I came to India last December was this. We were discussing so much with my colleagues in Italy about flexible routes and above all small cars, small trucks. Instead, in India, I had the possibility to see that you are ahead these small trucks, these small cars, I don't know the names. With motorcycle, but I'm referring to these small these are my friends, Dr. Parameshashari with his family and Zarzarlin. So my conclusion are already given. So I was amazed because when I came in India in December, I saw that maybe you don't know, you don't realize that what you used for every day that you see every day is so important, but is very important. I don't know, I repeat, name of these machines, but they can be very useful to implement flexible mobility and other things. Thank you for your attention, and please ask me some questions, or let's give some discussion and observation about my presentation. I don't hear you. I see that Dr. Prakash is talking. Principal, my dear principal, I don't hear you.
Yeah, thank you, madam. Very nice of you. It was a very nice presentation.
Thanks to you. I feel that India has a lot of hidden potentiality you don't realize because for you is very normal. I mean, you see those small cars, for you is very normal. We had to study all a project to arrive to, to identify that smaller cars like them are important to realize, to achieve smart mobility. You have already, I know that can seem funny, but it's not funny. I mean, it's just to say that there is a lot of potentiality in maybe in each country, but I'm interested in this case to India. So there is a lot of things that can be identified and starting, to do something that can bring to a change in many aspects of the country, and the university has an important role, to draw these pathways.
True. Absolutely true, madam. What you told is absolutely correct. We have any more questions, Dhananjay? Any questions from the audience? Yeah. Shall I read it, madam? There is one question.
Yeah, thank you, Ashok Shukla. I hope that I pronounced it well, your name.
Correct.
The problem of Industry 4.0 in this case, I put a slide. I don't know. Maybe it's a little bit difficult to come back to my slide, but there was a job disruption, and the same situation was in Italy. But in Italy, that slide demonstrated that the situation in terms of numbers was not so different. What was different were the skills required. So maybe the number of required people in the workplace was the same, but the skills were completely different. So the big problem was to create the right skills for the new type of jobs that were needed in Industry 4.0. So there was in the last years a big effort, to change and to make people study again, to change their skills. Is not easy. It depends also on the age, obviously.
Absolutely,
Thank you,
absolutely.
Dr. Ashok, for asking.
Ma'am, we have another question from Dr. Shiva.
Thank you, Dr. Shiva.
Yeah, please guide us hints about intelligent use of big data in monitoring and nurturing the health of crops, individual samplings as UG student projects.
I mean, I work on sensors, wireless sensors, but as my friends know, the other presentation that I did in person was on monitoring, on using the satellite data to monitoring the health of our planet. So in your case, when you are talking of monitoring the health of the crops, I'm thinking to use the satellite data, because satellite data, it depends on the specific type of sensor on board of the satellite, but for the specific application, like for the crops, we can think to some specific satellites. It's possible to collect a lot of data. Also in that case, it's possible to talk about big data. And also in that case, it's possible to use machine learning algorithms to process the data and to retrieve some features or some particular information that you need. So it depends on what you want to do. You can even contact me. My email, I will share my email with everybody. It was in my first slide, is ullo@misannio.it. So you can send me your observation. We can discuss together about this, because this can be done through the analysis of satellite data. And we can also design a student project. I think that this is what you mean, UG student project.
Exactly. I think that's what he is.
Yes, please, Dr. Shiva, contact me, explain what we can do.
Sure, madam. I think we will get in touch. I'll speak to Dr. Shiva and we can able to take forward that project in association with you.
Absolutely. You are the first one, you and Jojesh, always.
Thank you. Any more questions?
Sir, I feel Madam was so nicely doing the activities, and she was explaining the slides so well that we are getting only appreciations on in the post rather than questions. So, Madam, everything was well organized and well said. Probably we have Dr. Yogesh sir here who would like to speak to you in person, and he will have some questions to be asked in case.
Madam, thank you very much on behalf
Thanks
of our international conference team. Wholeheartedly thank you for your kind time. We look forward for your visit once again in next year.
Absolutely,
and your photos which you showed, it recalled our back moments. It was very nice to see. Even Prakash sir enjoyed, I feel personally.
Thanks to you, Jojesh. Thanks to Dr. Prakash, to my principal, is also my principal. So thank you very much for all what you do, because you do so much with your institution. Yeah, so it's very honored for me to be part of your community. Really, I'm very happy and honored to have done this lecture, but to stay with you, even if virtually. I will send you my presentation. I will share with you my presentation. So you can, you can share the presentation with the attendees.
Sure.
Madam. Done. Very nice of you.
Okay, we'll wind up the session. Thank you very much, everyone.
Okay, bye-bye.
Madam, namaste once again. Bye.
Namaste, ciao. Bye.
Bye.
Namaste, madam. Bye.